So we'll start with the Laplace transformation. Okay. The Laplace transformation is all about converting a function from the t domain to another function in S domain. Okay. So you have a function in terms of t, and maybe it will have some graph. You will convert it to another function in terms of S. The independent variable will be S, and it also will have some graph. Now, some points are important. First point is that you only have a unique Laplace transform for any given f of t. So for each f of t, you will have one-to-one relationship. Okay, any function of t has only one unique function of f of s. Okay, now how can we do this transformation? The task is very easy. You have a relationship which is basically integration, because Laplace transformation is a type of integral transformation. You will integrate the function after multiplying it with this factor, okay, which is a function of t also. Okay, now let's have some examples. Let's transfer this function, which is just constant, and then this function e to minus alpha t. Okay, the first function is basically constant k. It can be drawn like this. If we put the k here, integration from 0 to infinity k, because the k is constant, we can move it outside the integration and integrate the e to minus st dt, and this is k to e minus st divided by minus s from 0 to infinity equals k. Evaluate the infinity inside the expression, you get minus infinity to minus s minus, then 0 to minus s. This will go to 0, and this is 1, so k into 0 minus 1 over s, which is k into 1 over s. You can simplify the expression further, okay, to get this result. Okay, it means that if you are given any function of t, which is a constant function, your result will be the number, the constant value, divided by s. Okay, now what about this function? Okay, let's have some space. The same thing will be applied. Plug in the function here and multiply it by that factor, e to the minus s of t. This is our function into e to minus s of t. Now we have the same basis. What we will do is adding the indexes. Okay, and this is e to minus t alpha plus s dt. Let's do the integration. Minus t alpha plus s divided by minus alpha plus s inside the brackets from 0 to infinity, and this will give us e to minus infinity divided by minus alpha plus s minus e to 0 divided by minus alpha plus s. Of course, it is 0 and this is 1, so 0 minus 1 over minus alpha plus s, and this will give you 1 over alpha plus s. Okay, so the transformation of this function is this. Now alpha is constant, is basically any number. Let's say you have f of t that equals to minus 5t. Let's choose another number because s and 5 are too similar. So here 3, put the 3 here, and this is your transformation. If this is plus 3, here will be minus 3, okay? And this is good introduction to the Laplace transformation, I think. Now, what if we have another function? Let's say f of t that equals to sine something into t, or another function cosine of 9t, or maybe combination of e to minus 3t into sine of 3t, for example, or 8t. You always can do the integration. You can do the integration to find the f of s of these different functions. And another way, another easier way, is to use this lookup table. You have this lookup table in the exam. You will be given the function. Let's see what were the functions. You have sine of bt. Okay, let's write them here. Sine of 9t, and the second function is f of t, a combination, for example, minus 9t into sine of 8t. Okay, you can look at this table and see where can you find an f of t which is similar to this f of t. Okay, here, the sine. Okay, it's similar to this. Now the b is the 9. Okay, so the f of s will be, just replace any b with 9. So 9 over 9 square, and here s square. Okay, what about this? Do we have any similar expression like this? Oh, here is it. Okay, now the a is this, and the b is this. Okay, if you can see. So the f of s will be b, which is 8, and s plus a, which is minus 9, but here you are given minus alpha, so 9, only 9. If this was positive 9, you would replace it with negative here. Okay, but it is but it exactly, if you can see, this exactly matches with this, so no need to change any sign. Be careful with this. Okay, plus 8 square, and this is your transformation. You can do the whole integration, it's okay, but you will take too much time. So this lookup table is always available in the exams and easier to deal with. Okay, you can do some more examples if you have some handouts or books using this table. It's so easy. Okay, I hope so. Now let's talk about some properties that the Laplace transformation has. Okay, the first property is the linearity. And the meaning of the linearity is you have some rules that can be applied to the Laplace transformation. For example, let's say that your function of t is equal to two functions that are added together. You can always distribute the Laplace transformation to each term of your whole function. Okay, this is called the distributive property. Okay, also if you have a constant that is multiplied by your function and you want to take the Laplace, this is similar to putting the constant outside the Laplace transformation and transfer your function. When you finish, just multiply the constant. We actually have done something like this when we integrate the constant k, the function, the whole function, okay? So the whole function was k, but there wasn't anything multiplied by k. Now, why is this true? Why is this true? These two rules. Because the Laplace transformation is basically integration. And the integration is linear. The differentiation also is linear operation. So you always can do distribution and taking the constant outside. It works, okay? So this is the first property. Let's do an example, or let's say you have these examples, okay? Let's say you have this function, sine of 9t plus this function, e to minus 90 sine 8t. If you are going to find the whole Laplace transformation, you can find first this Laplace transformation and add the Laplace transformation of the next term. Okay? I think this is something which makes sense, okay? And here your answers, okay? And this is linearity. Okay, the second property of the Laplace transformation is called shifting. Okay, we have two shift theorems. Okay, the first shift theorem and the second shift theorem. We are going to discuss these in next video, but just to give you an overview, we have also something called the final and initial theorems. Okay, I'm sorry for the handwriting, for the bad handwriting. Okay, and we will see these two theorems in the next video. Okay, and then we will do the inverse of the Laplace transformation. And the inverse of the Laplace transformation is the opposite. You have the function in terms of s, and you want to go back to your function in terms of t. Okay? And the tool that we are going to use is called the partial fractions. Okay? This tool will enable us actually to find what was our function with the help of this table.